Welcome to our review on the transition metals. First thing we need to know then is where we find the transition metals on the periodic table. So these are actually located between groups 2 and 3, so in that big block in the middle basically. Key things we need to remember about them: they are all metals. As the name transition metal suggests, it's not a trick, they are all metals. Therefore their typical properties are that of metals as well. They're shiny when they're freshly cut, they're good conductors of electricity, they're strong, they're malleable. If in doubt, go with a metal property and it should be right. So if we actually compare group 1 and our transition metals, then what we're going to see is that our transition metals are stronger, they're harder, have a higher density, and they have a higher melting point. So not only do you need to remember just the general properties of our transition metals, but just remember those comparisons with our group 1 metals, the alkali metals as well. If we now consider the chemical properties, then what we find is that our transition metals react very slowly, if they react at all. So one of the key examples that we've encountered in our C4 topic, and we will encounter again in C6, is the one for rusting. So we've got iron and it will react with oxygen and water to make hydrated iron 3 oxide. So that happens over a very long period of time. It's not like if you leave a bit of iron outside overnight, it's just rusted away by morning. It takes an extended period. If we consider some of our other transition metals, things like platinum for example, then they do not react with water or oxygen, which is why that makes really good jewellery, because it's not going to react with the oxygen or the water that you come into contact with while wearing it. The other thing to bear in mind is that when we're talking about our transition metals, they can actually form more than one type of ion. Now, the way we know what charge we have on that metal ion comes from the Roman numeral they place in brackets. So we're not going into very detailed Roman numerals. You don't have to go and get a book out and learn them all. Just know the basic ones. Okay, hopefully we know that a single capital I means 1, 2 capital I's is 2, 3 capital I's is 3. That's going to cover what will come up on your GCSE exam. So when we're looking at our example I've given you at the bottom there of iron with the 3 I's in the brackets, oxide, then that tells us it's iron 3 oxide, so the ions we make will be Fe3+. If we had iron with only the 2 I's in the brackets, that would make Fe2+ ions. When we're considering the kind of compounds that are made from our transition metals, key thing to remember here is that they produce these really quite pretty coloured compounds. Whereas our alkali metals, when they produce a compound, they're usually rather dull by being white or colourless. So if you've got a lovely purple or green or blue, chances are it's a transition metal. If it's white or it's colourless, chances are it's an alkali metal. Not guarantee, but a good bet. Our transition metals are actually incredibly good catalysts, and if we remember, a catalyst is something that speeds up a chemical reaction without being used up themselves. So when they ask you to define a catalyst, it could be worth 2 marks. First one, speed up chemical reactions. Second mark, without being used up themselves. They also sometimes ask you questions to identify which is a catalyst from some information. Look for one that's increased the rate of reaction, so made it happen quicker, but the mass of our catalyst has stayed the same before and after, and that it also hasn't changed, so it's the same colour, etc. Last thing to consider is where we might actually find some of these transition metals used. And one of the common places is in catalytic converters in our cars. So they use platinum or rhodium and palladium, and the whole purpose of putting those into the device within our car is that it's going to convert those harmful exhaust gases into less harmful ones before they're released into the environment. Hopefully at the end of this video you can now recall the general properties of those transition metals.